In question 25A part 1 we have a cell connected across a resistor. We're asked to state one similarity and one difference between electromotive force and potential difference. Well, a similarity, they're both measured in volts. A difference, EMF, is the transformation of chemical energy to electrical energy, and potential difference is the transformation of electrical energy into other forms. In part 2 we're asked to calculate the mean drift velocity of the electrons when the current in the resistor is 3.0 milliamps. Well, using the equation current is equal to charge carrier density times cross-sectional area times drift velocity times the charge on the electron, we can rearrange as V is equal to I over N A E, and then with the values, I is 3.0 times 10 to the minus 3 amps, N is 1.3 times 10 to the 25, A is 1.2 times 10 to the minus 6, and the charge on the electron is 1.60 times 10 to the minus 19 coulombs. This gives an answer of 1.2 times 10 to the minus 3 meters per second. In B, where we have a student given a chemical cell, ammeter, voltmeter, variable resistor and connecting wires, and we're to design a lab experiment to find the internal resistance of the cell. Okay, well, the circuit we'd draw, we'd need the cell itself. Within the circuit we need an ammeter. We also need a variable resistor. Across the power supply we need a voltmeter. And then, as terminal potential difference is equal to EMF minus the current times the internal resistance, we can rewrite this equation as V is equal to minus R times I plus the EMF. This is then of the format Y is equal to mx plus C. So we would vary the variable resistor. We would record current and potential difference for several values. We would then plot a graph of the terminal potential difference in volts against the current in amps. We would have a negative gradient, something like this, and the gradient is equal to minus the internal resistance. Incidentally, we don't require it, but the EMF is given by the y-intercept.